Good afternoon, and welcome to Science with Ms. Steph. This is episode 66 of Science with Ms. Steph. Welcome, welcome, welcome. Let's have some nice science fun, everybody. Welcome to the lab. Hi, and yes, the lab has relocated for this afternoon and possibly next week as well. Okay, the lighting is a little different, so just kind of work with me. All right, great to be with you all today. You are welcome to my kitchen. Did you know that the kitchen can be a laboratory as well? So yeah, the reason we're in the kitchen is because I didn't. Let's do positive framing. That's what we do as teachers, right? Positive framing. I wanted to make sure that the potential mess wouldn't be too crazy. Okay, so yeah. Also, another reason why you're seeing me at this time and in this way is because I decided to just kind of change things up a little bit, right? So welcome, welcome, welcome. Today, I am trying a little something new and different. I actually am just coming from Instagram. Okay, I'm going to do a quick little rinse of my container, my reaction vessel. Yeah, just coming over from Instagram to you all because I decided that I wanted to see how it goes if I do the activity twice, right? If I go ahead and give everybody their due attention, all right? So I did the activity, the demonstration on Instagram already with Orange Fanta, okay? And I am thinking that this can be a little bit more of a long form kind of thing, right? It's hard to be on Instagram for a really, really long time. But I think that you and I can have a really, really great time today hanging out and talking about some things. One of the things that we need to talk about is hello. I really want to drive home the fact that we are on year 10 come July. Okay. Well, actually, June. June 1st, 2012 is when I started Triple F Empowerment. And we then launched Summer Science Club. The first Summer Science Club was held July to August of 2012. And this summer, if you do the math, I know the math sounds a little weird. 21 minus 9 21 minus 12 is 9. However, y'all know how things go with that next year or whatever. So this year, we are finishing up year 9 of programming and launching into year 10 come June. That's what I'm saying, okay? I know I'm saying it some complicated way just because science brain. Sometimes I get a little excited and over-explain, right? But bottom line, year 10 is fast approaching. We are approaching year 10. We're excited about what that means and the potential for more and more young people to be inspired to become scientists. And so we have our campaign going. You know, we always do a summer science club fundraiser, and just know that when you are contributing to that to us, you are helping us do a great work. Okay, more and more young people will be inspired. Okay, we do have Summer Science Club, which tends to be a small nucleus of children, but know that one, those 10 children then go off to do great and amazing things. And it is only 10 children this year, simply because of the global situation that we've got going on. I'm not going to call it by name right now, just today. That's just where I'm at. And as far as the other things that I do during the summer. I do consulting and helping other programs running their summer camps and so forth. And so it's actually hundreds of kids. It's 10 kids directly hanging out with us in our summer science club classroom, but it's actually hundreds of kids in any given summer. Okay, so as far as today's activity, I want to really drive home the imagery that multiplying something literally just by 10, okay, just by a factor of 10 can change the trajectory of an experiment, can make for a bigger reaction. Okay, so we're going to do this, like I said, with Coca-Cola. Now, when I did it with the Fanta, and like I said, you can check that out on Instagram. When I did it with the Fanta, I kind of got, okay. Well, it was okay. I mean, it wasn't like amazing. It wasn't amazing, but it was okay, and it definitely did overflow. And it definitely let me be quite happy that I'm over here doing this in the sink. Okay. So for those of you just joining me, hi, I'm Ms. Steph, and we are rocking out episode 66 of Science with Ms. Steph. Yes, people, episode 66. Okay, and for this investigation, you need a lot of research, like a ridiculous amount. Okay, as in 6 packets, right? Because they come 2 in a pack. We're going to do a comparison of the impact of, a comparison of the size, the magnitude of a reaction based off of the amount of chemicals you're adding. So we're going to add, okay, 10 times the amount of all of the reagents into this container that we're doing into this one. Okay, so I actually need 2 of these cups. One of them is going to hold all of my Alka-seltzer, right? I'm just going to get together all this Alka-seltzer. Like I said, over on Instagram, I'm doing a bit more of a long form with y'all, right? So I'm going to really walk you through this. I am opening my Alka-seltzer. I need 1 more cup. Okay. I have, like y'all can see, I have a lot of science equipment with me today. All right. So I am rocking out things today, really excited to be with you today and get a chance to really try something new. Okay. So some of you may be wondering, like, where does she get the idea of Alka-seltzer, Mentos, soda, and soap? Like, who would think of such a thing? Well, guess what? I got it from the interwebs. Okay, there's these different experiments that people do online, and you think to yourself, especially as a scientist, you're like, that's not what happens, right? And so there's a couple of folks going around YouTube. No shade to them. I don't know them. This is not some like whatever, but just as a scientist and a science instructor, wanting to make sure that we're communicating properly with young people and not, trying to say, oh yeah, sure, if you mix this and this, this is what will happen. And then in reality, that's like not accurate science. Okay. So that being said, there's this thing called like devil's toothpaste, right? I'm sure you've heard of elephant's toothpaste, and guess what? We'll be doing that next week. And it's a tried and true thing. However, there are different ways and different activators and different just alterations you can make to the elephant toothpaste to have it turn out in a certain kind of way. And so as I was doing that research and finding stuff, I'm coming across all kinds of crazy information about this thing called devil's toothpaste. Now, there's 2 different ways, general ways to kind of make it. And one of them was, I have background, okay, and it's fast. And one of them was trying to say that if you basically take the Mentos cola, okay, reaction and add some baking soda or Alka-seltzer to it, you would get this huge thing that like puffs out of the ground and all that. That didn't seem to make sense to me. However, I ran into it several times. And what does make sense to me is investigating. What does make sense to me is being curious. What does make sense to me is trying it, okay, in a responsible way. All right. So back to our theme for May is times 10, the power of 10. Are you going to lend your power of 10 to us, right? When you're thinking about supporting us for the summer, add a zero behind whatever your donation was going to be. Trust me, I'm about to show you how adding a zero behind all of the measurements just changes things in a big way. Okay, so 10, 10, 10, 10. For the big one, 10 Alka-seltzer tablets. So I've got 4 here, 6. So I need 4 more, right? Okay, 10 Alka-seltzer tablets. I'm going to do 10 Mentos. I'm also going to do 10 times the amount of soap that I'm putting in the smaller sample, smaller situation, right? Over on Insta, I did Mentos. I have to count out my Mentos. I did, let's tilt you down, all right, so that you can see me count the Mentos. Okay. I did add the, I did add the reagents, right? A certain amount of everything except for the soda down in the bottom. And then I poured in soda. Okay. Can you see? There we go. And so I told folks on Insta, I was going to come over here on Facebook and change that order and see if that makes a difference. All right. So I'm actually going to add the soda into both of these first, into my reagent cups first. All right. So this needs 1. Because remember, we're doing 1 and then 10 times. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And of course, as you can see, I've got Alka-seltzer and Mentos in here, and I need to add an Alka-seltzer here, which is just half of a packet, right? Rocking out our math, folks. Math matters. Math is helpful, okay? Inside of this container, we have 591 milliliters, okay? So when we're talking about doing 10 times in one of them, okay, I've already kind of done out the math. I've decided that I'm going to do 50 milliliters into this smaller reaction, all right? And then I'm going to do 500 milliliters into the larger reaction, okay? So my plan is to essentially stop short of adding all of what's left, because you and I both know that 591 minus 50 is actually 541, right? So I can't add all of this. That's not, if I were to add all of the rest of this after I subtract the 50, that would be inaccurate. Okay, that would be going over just a bit. All right, I'm going to do this pretty quickly because we know that we don't want our soda to lose any of its CO2, right? So I'm going for this first one. I said I was going to add this last. All right. I'm going to add my soap first, 1 swirl, and then over here I'm going to add 10 swirls. So again, I'm telling you, I'm just doing this off of what I saw online that made me go, that seems like that's not going to do what they're saying it does. Okay, so if you go on YouTube, it's going to, this is actually kind of a debunk. Sorry guys, I know that might sound like this stuff is being shady. I promise I'm not. I'm just wanting you to have a true, genuine understanding of like science. Okay, and so if you go on YouTube and type in like Coke and Mentos Devil's Toothpaste or whatever, you'll see these materials, and then some big, huge, like bright colored snake can come out of the ground. Okay, so just based on this reaction, tell me, do you think that any multiple, right, of these reagents would give you that? Eh, eh, okay, right? At the same time, like I said, power of 10. Yeah. Power of 10. So let's go ahead and do it times 10 and see if that will make a difference, if that will change the size and the magnitude of the reaction and change whether or not we get something that's a little bit more interesting than like bubbles. Bubbles are fun. Some of my favorite activities and investigations create bubbles. But I just feel like that's not the same as calling something devil's toothpaste. Right. Just saying. All right. So going to add soap. I'm eyeballing it, but remember in this container, I am adding 10 times the volume of reagents. Volume or number of, right? I used one Mentos last time in this Coca-Cola situation. This has one Mentos, like a couple of squirts of my clear liquid dish soap, and it's got one Alka-seltzer tablet in it. You can tell it's still kind of reacting because Alka-seltzer, no matter what, is going to react with any water contained inside of a liquid. Okay. In this container, this is how science teachers use housewarming gifts. Um, one of my lovely former students slash mentees sent me some flowers for my new apartment, and I saved this for such occasions as these. As this, right? So I've got soap down in here. This is kind of sort of a plastic. I think it's a plexiglass situation. Okay, I've got soap down in here. You saw I put quite a bit of soap down. Okay. Okay. And as promised, I'm going to add my 500 milliliters of Coca-Cola. I'm going to do it pretty fast because then I want to very quickly after that go ahead and add my 10 by 10, my 10 Alka-seltzer tablets and my 10, I know it's ridiculous, my 10 Mentos. Okay? Do. Pour. Let's tilt y'all. And pour at the same time. Hopefully y'all can see what's going on. Do. And I'm going to stop just short of the whole thing. See, we all know that soda just kind of overflows anyway. Let's see if we can get it to do a little bit more. Okay? Again, this is the Ms. Steph test of what these people are saying causes this huge, giant devil's toothpaste alternative. Yeah. Do y'all see what I see? I don't really see this big, huge reaction per se. Now it is speeding up. I'm going to move you a little bit because that's the fun thing about this camera. Hopefully it's going to cooperate. Nope, it doesn't like. Okay. So you see you're getting a situation to where it's starting to react. So I'm getting a reaction. The reaction is coming. It's happening, right? But is it this huge, giant overflow that would make you think, Miss Steph, get out of there. You're in danger. Probably not. Right? down here at the bottom, down at the bottom, you can see that the Mentos are just kind of hanging out. All of this bubble situation is coming from Alka-seltzer, the acidity and the water content of our soda, okay? As well as it's the gas that's then created with that reaction being captured by the soap, okay? So, I mean, I'm getting a really pretty fruitful reaction, long reaction. I already ignited things, as you saw, by pouring in my soda. Soda being poured quickly in itself produces a bit of an overflow if not managed properly. And then, of course, like I said, the soap and the Alka-seltzer really are what what is driving this reaction at this point. Okay, the Mentos is just hanging out down at the bottom, because we learned the last time I did an activity like this, we learned that the reason the Coke or the soda and Mentos geyser even functions is because you're quickly adding Mentos that has a rough candy shell inside of something with a very high concentration of carbon dioxide. And that carbon dioxide gets disturbed. All that carbon dioxide that's been dissolved inside of the soda, which is the thing that makes it soda, right? That's why we call it soda. Is disturbed and changed and moved around and gets excited and then comes out and pushes out with some of the liquid as well, right? Which is why you get that geyser, really, really cool effect. But in the end, I would say, without meaning to do so, I kind of debunked some of those videos that are hanging out on YouTube. So yeah, looks like I've got some Alka-seltzer, I think, all over me, and Mentos all over me, but that's what it is to be a science instructor. It's fun. You get a little messy sometimes. But this has been episode 66 of Science with Ms. Steph. Please, please, please make sure that you are checking out all the different things that we have online. And I mean, we have a lot of, let's see how precarious this is. We have a bunch of stuff that is available to you. And we're also inviting you to partner, right? Partner with your power of 10. What can $10 do? $10 can go very far. $10 is 72 minutes during summer camp for a child to have STEAM experience. $100 works out to over 12 hours. 12 hours for a kid to explore, okay? Yeah, partner, y'all. Also, we have some videos that are coming up because I'm sure some of you are wondering what has happened with some of our awesome scientists, with Ramel, with Orlando, with Maxwell, with Max, Double X, all of these kids, with the Jones girls. Those stories are coming to you. They are opening up themselves to you to let you know how Science Club has impacted them. So keep an eye out for that. Yeah, folks, I mean, it's been fun. Thank you so much for watching episode 66 of Science with Ms. Steph. Y'all, we're going to switch this up a bit, and it's going to be fun. Yeah, next week, elephant toothpaste to the power of 10. It's going to be crazy. All right? Until next time. Thank you for watching Science with Ms. Steph. Make sure that you like this video and follow us on our various social media outlets. Don't forget, please lend your power of 10 to our exponential growth campaign. Have an absolutely wonderful afternoon.